Welcome back to Geometry. We're in Chapter 12, Section 3, Sector Area and Arc Length. Pause the video, come back, and check your work. Did you recognize the 30, 60, 90 right triangles? I hope so. So in that case, if we have a hypotenuse of 40, that equaled what? A times the square root of 3. So A must be 20, right? So we have W, which is the second leg, and is 20 times the square root of 3. And Y over here is going to be 40 square root of 3 over 3. And Z, the shortest leg, would be 20 square root of 3 over 3. Okay? And so we're going to have another little piece of the warm-up here. See if you can find arc RT and UQ. Okay, remember the arc is found by finding the central angle that goes with it. So 126 plus what gives you this 180 here, and that would be 54 degrees. So arc RT is 54 degrees. And then UQ, U to Q, here is being bisected by this perpendicular radius. And if this is a radius, then it must equal 4 feet, right? This is another radius, so we have a radius here of 4. And so do you recall how to find our UQ? And you should have 4 times the square root of 2 feet. So today we're going to find the area of sectors and find arc lengths. So we need to know what a sector of a circle is, a segment of a circle, and arc length. So a sector, the area of a sector is a fraction of the circle that contains the sector. So to find an area of a sector that has a central angle m degrees, we multiply the area of the whole circle by that part over whole. Central angle measured degrees over the whole 360 degrees in a circle. So here we have sector ACB. So the sector is this region of the circle. And so we can find it by simply multiplying that percent of 3/6 of the whole, right? So m degrees over 360 times the total area of the circle. That'll give us the sector area. Okay, so imagine that this was 90 degrees. So we would have 90 over 360, right? Or 1/4 of the entire area. Sometimes it helps to just think of it in the form of a sample. There's a helpful hint that when you write the degree symbol after m in the formula, it helps you to remember to use degree measure and not arc length in the little formula. The formula for the sector area is the area of a circle times m degrees over 360. So let's find the area of each sector and give our answers in terms of pi, which is nice. And then round your answer to the nearest hundredth using 3.14 or your pi key on the calculator. So sector HGJ has a central angle of 131 degrees. And it has a radius of 12. So we can simply start with our formula, which is the area of a circle times the part over whole, the percent of this sector. So 131 over 360 gives us that, and we can just plug in our radius of 12. And when you do, we can begin by leaving our answer in terms of pi, and then we can round it to the nearest hundredth, which is 164.62 meters squared. Go ahead and pause the video and come back and check your work here. This is just like the last one. Okay, if you're back, we have 25 degrees over 360 this time, right? And a radius of 5. So you simply substitute, and we have 1.74 pi feet squared, or 5.45 feet squared. A windshield wiper blade is 18 inches long. To the nearest quarter inch, what is the area covered by the blade as it rotates through an angle of 122 degrees? So a windshield wiper blade is, I'm sure you've watched them on your windshield, even though we do not have that much rain, they form a arc and they wipe off what would be considered a sector of a circle, right? So we can simply use what we've learned to find the area that the blade is covering as it rotates through 122 degrees. The length of the wiper is equivalent to what in our formula? That's right, radius. So let's go ahead and begin with our formula and substitute our known values, 18 and 122. And when we do, go ahead, pause, come back and check. And you should have approximately 345 inches squared for that windshield wiper blade. It's your lucky day. That's what we're going to do today, is just look at these sector areas. That's it. So pause this video, come back when you have answers. Area of this sector LQM, length of arc NP. And there you go for the first day. Come back tomorrow and watch the rest of this video for day 2. Here we are in day 2 of chapter 12.3, and that is sector, area, and arc. So today we're going to focus on arcs, I believe, right? We're looking at segments too. We have the segment of a circle. And a segment of a circle is a region that is bounded by an arc and its chord. So here we have area of a segment. Notice it's not a complete sector. So it would be the area of a sector and then subtract the area of the triangle, and you have that little beautiful piece of a circle area known as the area of a segment. Okay, let's find the area of segment L and M to the nearest hundredth. Let's begin by finding the area of sector LNM. And so imagine this entire thing was shaded. We begin with the formula we were using yesterday, right? And so we have pi r squared times this percent, 120 over 360. And so we have a radius of 9, and we substitute our 120, and we can find that that sector area is 27 pi. Okay, now we need to find this triangle, don't we? And what do we know about this triangle? Well, what type of triangle is it? Yes, it is a isosceles. We have a 9 centimeter radius for each leg, right? And then we have this long side opposite. So how will we find the area of the triangle LNM? Well, we know that NO would give us the height we need, the altitude. We know the central angle gave us this angle, LNM, which was 120 degrees, right? 120 degrees. So the other two angles are congruent because it's isosceles. 180 minus 120 is 60, so they each must be a 30-degree angle. So that's nice. So we can create here 30, 60, 90, right? This is a bisector if we form a right triangle here. So we've got two 30, 60, 90 triangles. And we know the legs are 9 units long, right? So we can say then that the base must be 9 times the square root of 3. And the height must be 4.5, which is half of 9. Remember, the hypotenuse is 2a, and the shortest leg is a, right? So 4.5 is the height. And I'm sorry, the base here, we need to take a look at that again, because it really, if the shortest leg is 4.5, then the base would be 4.5 times the square root of 3, right, of this small 30, 60, 90. So we have two of those, 4.5 square root of 3 plus this other 4.5 square root of 3 to give us the entire base of this entire triangle. So we have 9 times the square root of 3 times 4.5, all divided by 2 or multiplied by 1/2. So let's find that. And we have 20.25 times the square root of 3 centimeters squared. So that's your area of the triangle. Okay, I had to pause and talk to somebody, and I'm back now, and I hope I'm not repeating myself, but we have the area of the triangle here, right? And so let's now move to step 3. So we have the area of the segment, which is the area of the sector, the entire sector, and then subtract the area of the triangle LNM. So we need to do that. And when we do, we end up with 49.75 centimeters squared. And that's this region here, which is known as the segment LNM. So in the same way that the area of a sector is a fraction of the area of the circle, the length of an arc is a fraction of the circumference of a circle, right? So arc length like arc AB, is a part of a fraction of the entire circumference, right? So arc length is the distance along an arc measured in linear units. So imagine we cut apart the circle at A and B and stretch it out straight and measure it. What is that distance? Well, that distance is the circumference, which also could be written as pi d, right, times the percent that arc covers, or m degrees over 360, part over whole. So let's find each arc length and then give answers in terms of pi and also round it to the nearest hundredth. Let's find arc length FG. They give you the angle, or the measure of arc FG is 134 degrees. So we could find the percent that this arc is of the entire circle by putting 134 degrees over 360 degrees, and then we just multiply by the circumference of the circle. So this part over 360, the whole times circumference, which is 2 pi r, or pi d. And we plug in these values. And go ahead and pause, come back and check your work. And you should have 5.96 pi, approximately 18.71 centimeters. This is linear, so centimeter. Okay, how about this? This is an arc with a measure 62 degrees in a circle with a radius 2. Okay, once again, let's start with our formula. So we have circumference times the percent that this arc is, which is 62 out of 360. This is area of a sector. Notice the symbol we use for that. Okay, and now we substitute, and you should have 0.69 pi meters, or 2.16 meters. That's all for today. You do have time to walk through this lesson quiz. Please do come back and check your work. Number 3. Number 4, the area of the segment. So we had to find the sector and subtract the triangle, is 55.94 meters squared. And there's your day 2. Isn't it nice splitting these into 2 days? Woohoo! Have fun.